Hey guys, so this video is going to focus on how to add two rational expressions together. So when it comes to adding or subtracting rational expressions together, what we need to try and keep in mind is that they pretty much follow the exact same format as adding and subtracting, just two any old regular fractions that just have numbers together. We still need common denominators. We need to convert our fractions to have those common denominators. Then we can finally add and subtract, and we must always check to make sure that we can simplify or see if we can simplify in the end. So let's get started here. So here's the example that we're going to be working on for right now. So for this particular example here, we definitely do not have the same denominators here. So our first step is to find common denominators. Now when it comes to finding common denominators of rational expressions, so your common denominator is pretty much all the different factors that you would put together in your denominators. So depending what your denominators looks like, you definitely want to factor your denominators, and then you kind of want to piece together all the different factors. All right, so if I'm looking at this, this example here, so I have a denominator of a plus 1, and then I have a denominator of a minus 1. So if I look at a plus 1, we can't factor a plus 1. There's no greatest common factor. There's no factoring technique that's going to allow us to factor that. Same thing actually when it comes to the denominator over here for our second one, a minus 3. There's no possible way that we could factor that. So our two different factors are a plus 1 and a minus 3. So actually our common denominator is just what we would get when we put them both together. So our common denominator for this problem is just a plus 1 times a minus 3. Just put them together. All right, all the different factors that you have combined all into one. So that's what our common denominator would be here. Now, step 2 is going to be to convert your fractions. So what we're going to have to do here, so I'm going to take the first fraction, 3a over a plus 1, and we want to convert that to have our common denominator. All right, so a plus 1 times a minus 3. And then we're going to take the second fraction and do the same thing, 2a over a minus 3, right? But we want it to have the same denominator as our common denominator. So we need to convert these two fractions together. Now when we convert the two fractions together, so let's start with this top one right over here. So what you always want to do, or what your thinking process is this. So you take a look at your current denominator and you think, what do I need to multiply that by to make it be my common denominator? So I have an a plus 1, but I need it to be a plus 1 times a minus 3. So essentially what we need to do is to change this denominator into this one. We need to multiply by what is missing from it. We have the a plus 1 already, right? So we have that part. What we need is the a minus 3. So what we're going to do is we're going to multiply top and bottom by a minus 3. So we're going to actually multiply that across. Remember, when you multiply fractions, it's top times top, bottom times bottom. So over here, what we're going to do is we're going to take 3a times a and then 3a minus 3. So we're going to distribute here. 3a times a is 3a squared. And 3a minus 3 over here is a negative 9a. We're going to pause here and let's convert this bottom one here. So looking at this bottom one here, we have a minus 3, but we need the a plus 1 to be a part of it. So what we're going to do here is we're going to multiply top and bottom by a plus 1. Now when we do so let's see, we're going to have to distribute again here. 2a times a is 2a squared, plus 2a times 1 is 2a. Now what we're going to do is we're going to put together back our two fractions here. So we had, let's see, 3a squared minus 9a, right, over our common denominator. So we're adding it here to the 2a squared plus 2a over that common denominator. Now, since we have common denominators now, we can move down to step 3 where we can actually add and subtract these things. So do remember when you finally add or subtract, you're just adding and subtracting the numerators, you're keeping the common denominator. So the common denominator was a plus 1 times a minus 3. That stays the same. What we're going to do is we're going to add the numerator. Now keep in mind when you're adding the numerator here, so you want to think about adding two polynomials together. Keeping in mind that you can only add together the like terms, right? So you need to combine like terms together. So your a squares are going to add together, and then your a to the first power is going to add together. So when we add this together, we're going to be doing 3a squared plus 2a squared. So 3 plus 2, that gives us 5a squareds. And then we have a negative 9a plus 2a. So negative 9 plus 2, that's a negative 7a. Okay, so that's what we get when we add them together, which means we are down to our last step here. Our last step is to simplify. And remember that when it comes to rational expressions, simplify really means factor. So we're taking a look to see, can we factor this thing? Is there any way for us to factor it and simplify it out? So taking a look at this problem, really the only way that it can be factored, looking in the numerator, starting with thinking, do we have a greatest common factor? Don't have anything in common with 5 and 7, though I do see that I can pull out an a here. And if I pull out an a, I'm left with 5a minus 7. But honestly, that doesn't really help me here. That does not let me cancel with anything down here in the denominator. So, I mean, I was able to factor the numerator, but nothing cancels. But unfortunately, or I guess, I don't know why unfortunately, but they consider that a little bit more simplified than this. You know, if it can be simplified, you need to do so regardless if something cancels or not. So this would actually be our final answer for this problem.